Okay, let's start. So today we're solving silver bullet. We have a binary and libc provided. We have a 32-bit binary dynamically linked, not strip, which is great for us. Then we have libc. I think we won't get symbols for this IDK. Let's see. Hmm. So 32-bit binary I open in this. Then that's done. Then we can say time being. We have menu, we have main, we have power up. So we have main. Couple of if else cases we have menu. Let's see. One is create, two is power up, three is beat the werewolf. All right. So we have two green, three, four. We have four options. Don't give up is one of them. We have invalid choice. Give me more power. All right. Wait. Power up first is create. So when you create, there's no malloc. So this might not be a heap challenge unless like you somehow exploit printf or whatever which uses malloc internally. Let's see. Takes a read input of 30 bytes. Your power is something based on str length. So the length of your string is your power. All right. S is provided as a reference, and when you do a create bullet, oh, this was a reference. We read x 30 bytes here, and then at 48 offset we write v2. This can be a structure. Always forget the shift F1 is struct. We call it bullet char name of 0x30. Then we have power. Yeah, so we can directly cast this instead of being this char s. We call it bullet s. Okay, power up. We need to change this. We also need to change this. Power up, create, and then you have beat. of which v5 is used. I guess I think this is the monster where werewolf. So we can create werewolf, and this should be int power and then cast our name. So power, this can be HP. That is what exactly used. So you have that to main, and you can cast v5 as werewolf. Oops. Oops. This should not be a pointer. There should be yes. Yeah. So then this is the werewolf. Hmm. And this is me. Yeah. So let's look at it again. This is your choice. So let's call it. We have a choice, and choice not to. Then this is two. We have first we have create bullet, in which a bullet is taken. Mm, if it has not already been initialized, then you can put in a name. Then the string length will be used as your power, and it will be assigned. All right. Now, once you have created it, you can power up. You have, I think this is a yeah, similar temporary variable. Let's cast it. This is not char. This is bullet local. Yes. Oh, you can't change the name. Okay. So we have the outer bullet here, the one we are using in main context. Then we have S, the local one. We null it if it has not been initialized. You need to create it, and it returns. If the power is already greater than 2f, which is I guess 47, you can't power up anymore. Print f, give me another version of description of bullet. You read, okay, so the read is done at s's name, then followed by already used length in this case. Okay, once you have that, then you do an strncat. Oh, strncat. What does that do? Strncat takes a destination pointer source and then the number of bytes, at most n bytes from src, and does not need to be null terminal, contains n or okay. The resulting string is always non-terminated. If src contains n or more bytes, therefore the size of dest must be at least strlen of dest plus n plus 1. Okay, so that means n plus src plus terminating null byte. I think that is not being done here. What does read input do? Read input is replaces your new line with a null byte. I think that is okay. I think this is the buggy part. We will be able to overflow here. Okay, we'll check that. Then you have updated power here. Return enjoy it. And once you have that, you can go to beat. If yeah, so if your HP is greater than wolf, which is not possible for length 48, so you'll sleep for some time and then decrement this check will verify that, and based on that it will return or not. All right, so do we okay, let's test our theory first. Let's test that strn gives us an off by one overflow. So we have already done, I think, chmod, yes. So to do that, what I'm gonna do is I'm gonna do take 47 bytes. First we create description is 47. It says your power is 47, which is all right. Now if I power up and I give it 1 2 3 4, your new power is 1. All right, we were able to overflow. So I think this is 4141 or 414140 something. Okay, 30. Hmm. 30 is because this is 48. LSB was changed to that value. Okay, let's look at how we beat the werewolf. Yes, so all right, so we kind of have our uh, primitive to overflow. Even without reversing, I think if we generate cyclic pattern, we will be able to cyclic. Let's run. We create length 47, and then we power up with length 4. Now new power is 1. Now we go and power up again, because I think it will be able to give me writes of 47 bytes. I think here I overflowed it and that's why it went into invalid choice. That will have to be careful of. Yeah, so this is the 6161. I think this is the part which we control. we can just beat the werewolf in this case. One more. Yeah, so now our pointer is this. We can do 7. At offset 7, we'll be able to control ret instruction, and we will have exactly 47 bytes of control after that. And I think that is the max we can achieve, considering we should be able to write 1 byte here. So the amount total is 48. So no way we are gonna get 48 bytes of control, considering we also overflow the length. Let me just verify. So here in this case, our bullet is stored as ESP plus 8, which should be about the case we have here. And this is where we overflowed. This should also have like hmm. So we kind of have a straight primitive. Now what we need is let's check sec. So for check sec we have no canary, that is like obvious in this case. We have an X but and no pi. But I assume there will be SLR on the server, and we have been given a version of libc. We also should not have ROP in this binary because it's a very standard binary. Let's check. This is some mutated I was writing for HTML and DOM. Okay, so in this case we have do we have syscall? No, we don't. But since this is 86, we will be able to call arbitrary functions since we have stack control to some extent. But we do not have any juicy function here. One thing that we can do is we can leak GOT entry for a function such as puts. And then since we have libc, we will be able to control or calculate the value of system and then call system bin sh. That should be the easy part. So to leak, we'll have to call puts with puts as GOT symbol. So that is gonna take 3 into 4. Let's see. Let's change this layout. Yeah. So to call, first we do plt puts, and then we need op ret, and then we need GOT puts. And this will leak us the input, or let's say this will leak us the libc. From here we will be able to once we have libc's address, we can call this again and leak environ. Oops. This will give us a stack leak. And then I can use where's that read input. So you can give stack offset here and n bytes, and then continue the rob chain. But this is dependent on this. Once you have this, then only we'll be able to trigger this. So we won't be able to leak libc.environ in the first try. Only once we get output from this raw part, then we're able to craft our second input to leak stack. So we'll not be able to continue the raw chain by using read input. So what I'm thinking is we can pivot onto this address. So how I'm gonna do is do that is once you have leak of puts, we'll be able to do read input, and then this address, actually we need pop ret, and then here's the count. So let's say x 101. Once you have that, then we should not be able to, we should not actually overflow. What? You're not able to somehow dump. Hmm. Now it should, yeah. What? We do not have. Why am I not able to resolve this function? Let's see. Okay, we have this here. I did not check. Oh, we have full railroad. That should not be an issue. Let's check. Let's do VM map. We have GOT in this section, so I should have verified that. So we still have many things to read from here. So which is good for us since we don't have anything of importance here, we can write after this address. Completed is, I don't know where this is used. So we can start writing from here. Now once we have that, we will be able to read here. Then do we have a pop EBP here? Since we do have a pop EBP here, we will be able to do pop EBP, oh no, EBP, and then you can say leave ret pop EBP, and this +4 -4 should be our address. And with this read input, we'll write our second payload to call system with address of, this is pop ret, which is pretty much not needed. Then address of slash Hmm. So this is our exploitation strategy. Let's work it out. So since we are not using malloc or anything libc specific apart from the offsets, we don't need to LD preload it to change any behavior or something of that sort. So I'm just gonna skip that part in pawn tools and directly use the libc provided as just for symbols. So first we need to create, we have as dot receive until this, then we send as dot to create we send one, then for create we need the description, instead of using send line should be able to do send. Actually it will patch that up with null byte. We should be able to do that. Let's debug this. I'll decide on it later. So you have that, then you have this, you have this. That's it for your power is this, and good luck. Then we have, after create we have to power it up. For power it up we need an updated description. I think this should be about the same. We use 6 gp and we do to another description same. Yeah, this is about the same. Enjoy it and good luck. No difference at all. Then you have beat to call this function multiple times. So to beat I need to say, okay, sorry, it is still alive. We need to verify. So only when we are able to beat the werewolf, only then we can return to our payload. So we need to beat it. Try to beat it. So first thing first, we can do we can send 3, and then we can say this is gonna be there line for this, not here, dude. 3, 4, 5. Then just try to beat it. Then we need to print at least one. Or you can say return not sorry in this one. I think this should be able to return true or false if we beat it or not. And we need to print this HP value just for debugging, I think. So mm, all right, so we have gdb dot attach, and then I'm gonna say attach to s. So first we create into 47, and then we power it with the I think a. So we need to change, instead of str line, need to change it. Need to power a, and then I think if we power a into 47, this should work. All right. Oops. Why did it do like that? Oh, I don't know why it failed. Let me check that later. Okay, so oh, we were able to increase our power to that value that we had earlier. Yeah, so when we continue, then let's say we beat it, and yeah, okay. So that is, I think, well enough for us. We were able to overflow into the saved instruction pointer. So here we start our upchain, which should be like this. Now we add context dot binary is equal to slash silver bullet. We need to write the first part of the upchain, so let's call it payload. So as we know, we need junk into 7 bytes. Then we can say then we have plt. So elif dot plt of puts to call puts. We need a pop-up ret in this case, so control F, pop. Yeah, so this is the pop-up red part. I'm gonna copy this. mm, we need to pack it. So you have that. Need P32. So if we are leaking that, we only need one pop red. I'm gonna do is this is okay. Pop is only 1 byte. Need God. So why did I do that? I don't know. Need to pack this too. So elf dot God outputs. Once you have that, then our plan was to do read input at this address. Okay, so so now we need to pack I think this address. Yeah, so and then we need to once we have that to leave. So leave red is okay. Why did I just copy that? I don't know. We have leave red and that's it. Now we need to craft payload 2 which should so payload 2 should contain address of system, then payload 2 should contain pop red. I think this is the value for that. And then payload 2 should contain uh, address of bin sh, which I think if we start writing at this address, then we add 1 2 3 bytes here, so that's 12 and 4 because I think this should be it. Puts is equal to, so we need to first leak is equal to s dot receive line, then puts is equal to u32 of okay 32 of So the first 4 bytes we unpack because that will be the symbol for puts. Once we have that, you can use this libc here for now, and then system as puts minus libc dot symbols puts plus c dot symbols system. I think this should be it. Length of payload is 1 2 3 4 5 6 7 8 9 6 7 8. It was 32 and 7 is 39. All right, so let's put up a breakpoint at the rate of main. Should be here. Yeah, so here we have right here, which is 8048 A19. All right, so once we have that, we need to do power payload and then send line payload 2. And this should be it. Okay, we have a breakpoint. Oh shit, we did not beat. We did not beat it. We need to do that. But did we overflow? That is a point. 4A4. Yeah, we were able to leak something, and then we are going to read this. Read input. Then we have pop EDI. Okay, this is not what we leaked. So we have read input. This is the pop. And that point we have the rob chain proper. We have this, but we somehow went blank just after writing this. Okay, to do that, let's make it. I think this should be able to suffice for now. Let's first defeat it then. Our payload is alright for now, but we need to defeat it. So I done is equal to beat, while not done is equal to beat. Okay, I think this should work. All right. Okay, so we were able to do that. Then we were able to leak. I don't know, we did not print it out. Okay. Next is the part where we read. So let's, you're reading at this address. Let's tell you that. Oh, I did not pop this into EBB, so this might fail. This will fail. What? All right, so we have a couple of mistakes for this. So here I need pop EBP, and then we need red. So for that I need this +1. I think that should suffice. And then we have delete surrounding quotes. Yeah, so we also need to print if we ever actually were able to leak. So it's a success hex of puts. So I'm only setting a breakpoint there just to verify. Oops. Need to run a lenter on this spawn tools once so that it warns me when function names are wrong. Oops. Whoa, so we have okay, we have that. Then we have leak of this. We can verify this is the actual puts. So print puts. Yes, this is actually puts. And we can say print system, and yeah, system is there. We can say continue, and then we can tally on the address that we were using. Yeah, did not need that +4 part, I guess. Somehow pawn tools failed here. Lately I've been finding a couple of bugs that I'm not able to explain fully. Did we actually seven? 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 4 times 36. No, we were actually in the limit. Then why have we not overflown here? Oh my god. If we are popping something, we need to pack that this value. Just a second. Uh, yeah, so we need to write this value. Then using red. Okay, so we need -4 in this case. I think this should suffice now. It's a lot of debugging on the exploit. No. Alright. Puts is okay. We continue. We kind of pop EBP, which is okay now. Yeah. And we say leave. Oh, so since we are at the start of the page, we kind of went into RW only R section, and somehow system was not able to use the stack for that case. So what I'm gonna do is we need to change this address. Rest everything is fine. We are able to jump to where I wanted. So let me write that as a variable. So now let's add let's say 800. I think that should be enough stack space. Let's see. Yeah, so that is all right. We were able to run our system. mm, Oops. Let's debug, disable the debug. All right, so now we need to change to this libc, and we should be able to be good on the remote. Let's see if this is, will this work? All right. Silver underscore bullet. Hmm. All right, so this is done. So let's recap for a bit. We were given a binary which was not stripped, so that was good for us. We are able to quickly look into what the binary was doing, how it was doing. There were a couple of structures that we wrote, totally minor, nothing major there. So we saw that we could create a bullet which only took a limited size of input of 48 bytes. But while changing, where the change go? Yeah. So while powering up, you could change that description, and it was using str and cat. And man, str and cat told us that we will be able to overflow 1 byte. So once we do that, our length, this s dot name, s dot destination dot par, this goes to 0. So we are able to write 48 bytes inside that. So this gives us an overflow of that many bytes. Once we have that overflow, we go, yeah, so once we have that overflow, we go and write our op chain that leaks GOT for us. And using that leak, we predict address of system and use that to call binsh. A pretty simple challenge like the earlier one that we did, that is hacked out. And this one has around 749 so times solutions. So I think that's okay. So that's it for this time. Uh, next stream might be in a couple of days.